Smoking has increasingly become a lifestyle, driven by the addictive pleasure derived from nicotine content. Badan Pusat Statistik note that the percentage of the Indonesian population aged 15 years and over who smoke was 28.62 in 2023. This percentage increased by 0.36 percentage points from the previous year of 28.26%. But nowadays, cigarette consumption in Indonesia changed rapidly into a new alternative to conventional variant called e-cigarettes, also known as a vape. Indonesia leads the world in vape usage, and the prevalence of vape use rising from 0.3% in 2011 to 3% in 2021, predominantly among men compared to a woman.
World Health Organization and Indonesia's Ministry of Health advise against vape, citing the risks of addiction, lung damage, and diseases like chronic obstructive pulmonary disease, lung cancer, and pneumonia. Reducing lung inflammation through anti-inflammatory agent is a potential preventive strategy for pneumonia caused by exposure to vape smoke. The use of traditional medicine, deeply rooted in Indonesia, has inspired research into shallot skin waste, which rich in flavonoids, alkaloids, saponins, and tannin for its potential as an anti-inflammatory properties.
Based on the background above, my name is Aneyra Arda Penjeraswari Ailsa,
and my name is Nashla Shazia Triarjanto,
and we are from SMA Negeri 3 Semarang. We conducted a research with the title
Potential of shallot skin waste as an anti-inflammatory and prevention of leukocytosis in the lungs of electronic smokers using the in vivo method and in silico approach.
Check it out our purposes below.
The research was conducted since November 2024 to January 2025, working together with several laboratories, guided by our supervisor with the following steps.
First, extraction process. Involves collecting 3 kg of shallot skins from household and market waste, cleaning, air drying, and grinding them into fine powder using a 16 massive. This powder simplicia is macerated in a 1:2 ratio with 96% ethanols for 4 days, stirred every 4 hours, and filtered through 200 mass filter paper to produce a concentrate extract. The extract solution is then transferred to a round bottom flask, heated using a rotatory evaporator, and observed for solvent evaporation while recording relevant parameters.
Second is phytochemical analysis. Shallot skin extract was sent to the chemistry laboratory of Universitas Negeri Semarang for testing to identify secondary metabolite compounds. This includes qualitative detection of specific compounds and quantitative measurement of their concentrations. Third is the in vivo test. 25 male mice were divided into 5 groups as detailed in the following table. Blood samples were collected in microtubes moistened with 3.2% sodium citrate and sent to the Semarang Animal Health Laboratory for leukocyte counts. Then, in silico tests. In silico tests were conducted to identify potential drug candidates from dominant secondary compounds in shallot skin, focusing on molecular docking simulation and toxicity prediction.
Qualitative phytochemical analysis was carried out, and the resulting data as can be seen in the following table.
Based on phytochemical tests, shallot skin extracts contains flavonoid, alkaloid, tannin, steroid, where flavonoid can reduce tissue damage due to inflammations. Based on the result of qualitative tests, we determine the total flavonoid content through the UVC spectrophotometry method using the quercetin standard. The results can be seen in the following table. The shallot skin extract contains a significant amount of flavonoids with a concentrations of 26.705 ppm. These compounds help modulate the immune response, potentially preventing leukocytosis by reducing inflammation and oxidative stress, supporting the potential therapeutic benefits of the shallot skin extract in managing inflammatory conditions.
In silico tests were conducted to identify potential drug candidates from dominant secondary compounds in shallot skin. 8 secondary compounds were linked to the target protein, protein kinase C gamma, associated with lung inflammation, as you can see on the following table. The bond energy, which indicates the stability and activity of the bond between a ligand and receptor, shows that abigenin, the most dominant secondary compound in shallot skin, has a binding affinity value of -10 kilocalorie per mole, suggesting its potential as an anti-inflammatory agent for active vape users.
And then, here's the leukocyte average total as in vivo test result.
It is known that the large decrease in leukocytes was in treatment group 3, with exposure to smoke from burning 0.8 mg of vape liquid every day for 10 minutes and given shallot skin extract 400 mg per kilogram body weight. This proves that the higher the amount of shallot skin extracts given to mice exposed to vape smoke, the high flavonoid content can suppress the production of leukocyte cells, thereby preventing leukocytosis.
The research concluded that first, phytochemical tests revealed that shallot skin extract contains alkaloid, flavonoids, steroids, and tannins with 26.705 ppm of flavonoid, suggesting its potential as an anti-inflammatory for vape smokers. Second, the shallot skin extract was made using dry powder and 96% ethanol, yielding 23 grams of solid extract and 62 grams of liquid extract. And third, in vivo tests showed that a dose of 400 mg per kilogram body weight of shallot skin extract had the most significant anti-inflammatory effect, reducing leukocyte levels and proving its potential in preventing leukocytosis in vape smokers' lungs.
Further, research should focus on daily blood sample testing to determine the peak of leukocyte spikes and on refining the extract production process following clinical trial stages to ensure safety for public consumptions. This will help develop a safety product that could attract public interest, particularly among teenagers.
Thank you for your attention.
Please support us in Indonesian Science Project Olympiad 2025. Bye!